When you look at all the devices in a data center, you can really put them into three main categories. First, you've got the servers or the compute, which are the brains that power the data center. Then you have the network, which is the backbone infrastructure on which everything in the data center relies. And the other one is the one that just gets forgotten about until it has a problem, and that would be the storage. Hi, I'm Rich. Welcome to the Rich Tech Guy channel. And in this video, I'm going to give some attention to that third and often forgotten category of the data center, or at least forgotten until it has a problem, be it not enough storage or you're not getting your data fast enough. And the storage may not be as cool or as interesting as some of the other parts of the data center, like the compute or the networking. But it's still nonetheless important. You need a place to store your data in the data center. So with that, before I get into the rest of it, if you like this content, go ahead and hit that like button down below. And also, while you're at it, if you haven't already subscribed, go ahead and hit that subscribe button too. So why have storage? After all, servers can have their own local storage. Why would you need a storage system? Well, to start with, a lot of operations in the data center are benefited by multiple servers accessing the same storage. You also have certain server platforms out there like Cisco UCS that utilize something called stateless computing, where the server doesn't really have any identity, essentially, and then it gets that from a config file. Once it has the config file, it goes and pulls the data that it needs to boot its OS and carry out its function, and in order to do that, the storage cannot be locally on the server. Also, storage systems are very good for data replication and being able to copy the data at different locations, so that way you can access the data locally rather than if you're at, say, a remote location or a branch location or even just a secondary office site. You don't have to go all the way back to the main data center in order to access that data if you have a replicated copy of the data stored locally. And then you also have a much better backup operation for a shared storage system, where if all your data is stored on that system, then you can basically get another storage system, and through those same data replication processes, you can copy and back up your data to the other system. A lot of these enterprise level storage systems also create something called snapshots, where it essentially kind of creates a freeze frame of what is on the storage system at a particular point in time. Now, I will stress though, snapshots are not backup and disaster recovery policy. Okay, snapshots are just simply there for making easy rollbacks, particularly of files if a change has been made to a file that you want to undo. But it's still a great option for that. So once you've established your need for a storage system, let's talk about setting it up. All right, when it comes to setting up a storage system, you are going to have little unique twists depending on the manufacturer of that storage system, but you are going to follow the same general workflow. And that workflow will be that first you're going to do the initial setup, and you're going to create all the management interface and set up the interfaces on the storage system. But when you're getting to actually working with the storage itself, the first thing you are going to do is set up RAID groups. Now, depending on the maker of the storage system, they may or may not call it a RAID group. NetApp, for instance, refers to their RAID groups as aggregates. And also, you may even not actually do this particular step. In the case of, say, Pure Storage, all the drives are just thrown together into one big RAID group, and you just move on to the next step. However, where you do have the ability to set up RAID groups, some of the vendors out there will even let you give or have some idea of what type of RAID group that you want to set up. And there are various RAID levels. To actually go into detail about the RAID levels, that would be an entirely different video, which I can make. But then you've got other vendors, again, I'll reference NetApp, that they have a set RAID level that they put the drives into, and you are basically locked into that. Now what a RAID is it stands for Redundant Array of Inexpensive Disks. I often laugh at the third one because when you actually see the price tags on these systems, inexpensive is not a word I would choose. But really what you're doing is you're taking a bunch of disks and you are essentially having them, from a logical standpoint, act as a single drive. You get some benefits out of this, and in addition to redundancy, because the way a lot of the RAID groups work is data will be copied across disks, so that way if one of those disks fails or becomes corrupted, you will still be able to access the data through the other disks. The other thing that you get, and this was really big and still is in the case of spinning disks, before solid state, but spinning disks are still used. And when you're reading off of a single disk, you have to wait for the head to go and get the data, and it's moving back and forth across the disk surface. But in the case of having multiple disks and the data stored being spread out across those disks, what happens is you're able to retrieve different parts of the data simultaneously and then build that together, which allows for a faster retrieval of your data. In fact, when you're talking to people in the storage industry, the biggest number that you'll hear them throw out is IOPS, input-output operations. And every storage vendor will talk about how their product gives you those extra bit of IOPS so you can retrieve your data faster. And in certain applications, the faster you get that data, the more critical that is relied on for the application. For instance, database applications, if you're ever running a SQL server, whenever it runs an operation, it always reports how long it took to get that data. So with databases and retrieving that data off of it, that is a very critical thing. Now, the other thing about RAID groups on the systems where you do have the ability to build them is you have to be careful when you architect out your RAID groups, because you can add disks into a RAID group after you have established it, but let's say you have added too many disks into a particular RAID group, and now you're trying to create a second RAID group, but you're not meeting your storage capacity. Well, removing disks from a RAID group basically involves destroying the RAID group. So it's kind of like a Price is Right situation, the closest to it without going over. So really you want to just sort of dial in as much data as you need, or space that you need. And if you have space requirements later that require you to grow that group, then you can add drives. But just remember, you can't pull it out without a very destructive process. And make sure you have your backups in place if you need to do that. The next step after doing the RAID groups is you're going to define volumes. And so a volume is essentially a logical allocation on the storage. So it's just a block of, say, how much, let's say a gigabyte, a terabyte, whatever, of space there. Now, when you're working with Linux and Unix type systems, that is where you kind of see volumes come into play much better than, say, on a Windows system. But on a Linux Unix style system, volumes are what are mounted for the OS. And that is where the OS will look at that and it will say, okay, I have a terabyte of space here, or I have 500 gigabytes of space here, whatever it is. But that is where the file structure is going to be built out. And also I will get into that as well, that in a little bit here, is the block storage versus file storage. And when you're talking file-based storage, that's where you're going to be at the volume level. And if you're going to go to block-based storage, then you're going to go one level beyond that, and that's where you're going to set up what's called a LUN. Now, a LUN is a logical unit. And in terms of block-based storage, the logical unit is effectively what that server on the other end is going to read as a hard drive. That the server on the other end is actually going to think that this logical block is an actual hard drive, and will treat it as such. Okay, so I've been talking about file storage and block storage. So what is it? Well, if you think about how data is stored on a drive, when you're at the block level, that is, let's say in the case of a spinning disk, that is the actual blocks on the disk where the ones and zeros are written. In the case of, say, an SSD, that's also allocated into various partitions with the ones and zeros. And that is essentially your block level. When you format a drive, you often specify block size. So that's really the smallest unit on a file. If you have a Linux system, what's really interesting is just open up a command and issue the touch and then write a file name. So just say like touch experiment. And what that will do is it will create a file called experiment, but it will be an empty file. And if you're looking at how the file is there, the Linux system will actually show that file as the size of the smallest block on the storage, because it's just basically dropped the file there and it's taken up that block. Even though the file itself is actually smaller, the file is really an empty file. Now, when it comes to the file-based system, well, once you've got all those blocks written out, then you're going to create a directory tree. And all OSs do this. So you have your directory tree, which is basically an index of the files. And the drive system is going to have that index where when you need to access a particular file, it's going to know which blocks on the hard drive or on the SSD are containing the information for that file. And so it goes and it looks in that location to pull the data. When you translate that into storage systems, the way to look at it is a volume or a file-based storage system is that storage system is going to maintain the directory tree. And when you access the data from that storage system, you are going to say, I want this file. The storage system will have its directory tree, look up the file, and go get it from the blocks that the system itself is managing. On the other hand, if you have a block-based storage system, the storage system itself really isn't going to know or care. Your server, your device on your end, is going to send the actual information to be written to the drives on the storage system, and the storage system is just going to write it. It is now up to your system on your side to actually maintain the proper directory trees and get the information as to where the blocks are on the storage system in order to access the data. The way we differentiate the storage systems is a file-based storage system will be referred to as a NAS or NAS, a network attached storage. And it will utilize protocols such as CIFS, Common Internet File System, which is predominantly used by Windows for a file-based shared storage. Linux Unix systems can also utilize CIFS via protocols or a program called Samba. But the Linux Unix systems actually the preference there is going to be for a NFS protocol, and NFS stands for Network File System. So the way NFS works is on a Linux system is you really just mount that shared storage volume as if it were a local volume, and the Linux system will actually see it just like it would see its own drives. The Windows systems, starting with Server 2012 and also Windows 10, are also able to mount NFS systems. But prior to that, Windows really wouldn't even do anything with NFS. It was only with CIFS. When you have a block-based system, it would be referred to as a SAN, or a storage area network. And a SAN system will utilize a protocol such as iSCSI if you're doing an IP-based block-based storage, or Fibre channel. The iSCSI protocol is essentially the Internet SCSI, or Internet Small Computer Systems Interface, and it utilizes of course, the Small Computer Systems Interface protocol, which is the SCSI protocol that is used by the hard drive systems for accessing data and writing data onto the drive. So what you're essentially doing is you're taking that SCSI protocol and you're just moving it across an IP-based network. And the way this works is, in a SAN-based system, you're going to have your initiator and you're going to have your target. The initiator is going to be the server that is trying to access the data or write the data. And then the target would be your storage system that is housing the data. And each of these are going to have what's called an IQN. And I'm going to display an IQN right there. What one looks like, but essentially it'll be IQN dot, and then it'll be a year and a month, and then dot, and it'll be kind of like a backwards domain IP address, or a domain address URL, and then some stuff after that sometimes. So you'll have your initiator IQN, you'll have your target IQN. Now on the initiator side, what you're going to do is you're going to tell you're going to have the data for the target IQN, and you're also going to have the IP address of the device that is hosting the data. So when the iSCSI initiator decides that it needs to access or write data on the storage system, it will send the request to the IP address that it has and provide its own initiator IQN, and also reference the target IQN. On the storage system side, all you're really going to put is the target IQN. And the way that works is on the LUN, the logical unit, is you're going to create something that would be like an initiator group. That's what NetApp calls it. Again, there's different storage vendors will have different names. But what it's going to have is it's just going to say, okay, this LUN can be accessed by this IQN. And when the request comes in from the initiator and it matches the IQN, it says, okay. And so it will take the data, or the data read or write commands, and process them and send whatever signal it needs back to the server, the initiator, to either provide the data that was requested in a read request or acknowledge that the write request has been completed. The other system or protocol utilized in a SAN-based system is called Fibre channel. Now I could do an entire video about Fibre channel, but Fibre channel is not an IP-based system. It utilizes its own series of protocols. And again, though, you're going to have an initiator and you're going to have a target. And instead of utilizing a regular switching technology, you're going to use what's called a SAN switch. From the Cisco line, that would be an MDS switch. Or brocade switches out there, those are typically SAN switches. And instead of IQNs, they use what's called a WWN, or a worldwide name. And just as a brief view, again, here's what a WWN looks like, and it really looks like a MAC address, but with a couple of extra bits or bytes to it. And then as that goes across, again, you set up the initiator group on the storage system that says any data from this initiator, WWN, can be accessed or can access this data. And then on the initiator side, you are going to give it the target WWN, and basically it says, okay, if you need to read or write data, you send it out through what's called an HBA, a host bus adapter, and instead of a NIC, a network interface card. It's going to go out through the host bus adapter and give the target of the WWN of the storage device. As I said, this is just a brief overview. I could go into much more detail about Fibre Channel, how it works, and also what you need to do in configuring the Fibre Channel switch that sits in between. All right, so that's storage in a nutshell. Now we can all forget about storage until we have a problem with it, right? But in all seriousness, if you like this content, go ahead and hit that like button down below. And if you haven't subscribed to this channel, go ahead and hit that subscribe button too. I'm going to post some links to stuff about storage and storage protocols that get used in the data center. They will be affiliate links, but if you like them, feel free to go ahead and check them out. And as I said, I could make a video about RAID groups or RAID levels. I could make a video about Fibre Channel, iSCSI, those types of protocols. So if you like that, go ahead and comment down below. And until the next time, keep learning, keep studying, keep improving. Thank you.